In this video, I'm going to show you how I made this game for my school project. It's pretty cool.
I'm only
young and living life a little reckless. Except I really haven't. I've been looking at my checklist. These also
Alright, something simple. Player movement. Pretty much in every game to ever exist in the history of ever, really. Here, I just programmed a little box to go left and right with A and D. Pretty simple stuff if I say so myself, and the code isn't that complicated. Up first, RB, which is short for rigid body. Rigid body is the component that you add to game objects to give them physics and all that. I've used fixed update because I'm using the Unity physics engine, and if you didn't put that in, it wouldn't really work as well. Now we're going to talk about the forward force, so rb.add_force, RB referring to rigid body of course. So you just add force onto that times time.delta time, which is so that you actually move, it's not run off by how many frames you're going, it's run off by how fast it's going in real time. Next up, we have public float, forward force and sideways force. This just tells you how fast you're actually going, and since we've used a public float, we can change that in the inspector in Unity, instead of having to go into the code and change it manually. Up last, we have the sideways force, which is pretty much the same as the forward force, but it's to the side. Anyway, I've used a simple if statement for D and A to go left and right. So if D is pressed, you go right, and if A is pressed, you go left. Pretty simple. Use time.delta time like before, so it goes in real time, not run off by frames. Pretty simple stuff. Up next, we have the camera follow player script, which is just so the camera follows the player. Let's get into the code. Up first, we have public transform player, which is so that the camera is actually attached to the player, but it actually doesn't work in the game, which is what the next line of code is for. And the next line of code is public vector3 offset, which is basically so you can move the camera around in the game, because if you moved it around with the inspector with public transform, it wouldn't actually go into the game. It would just change it in the inspector and the camera would just still be left behind. So public vector 3 allows you to change the position of the camera and follow the player, which is pretty cool. Up last, we have void update, so the camera follows the player by how many frames you're running off. But since we've used time.delta time in the previous script, that doesn't really matter, so the camera just follows the player all the time, no matter how many frames you're running at. Next up, we have player collision. When the player hits an obstacle, your movement stops entirely. Let's get to the code. Let's get started with the private void on collision enter, so that just verifies that the little grey obstacle that you saw in the video previously is actually a real thing and a real game object. With the previous code, so if collisioninfo.collider.tag equals obstacle, which is the little obstacle, little grey box you saw before, if that is hit, movement enabled is equal to false. So once you've hit the obstacle, your movement will slow down to nothing. Now that I've made a few more obstacles with the prefab that I've now made a full working level that's pretty short but works. I've also got new fog to give it more of a nicer look. You can change the density as you can see here. I've also done a new movement system to make it more snappy, because before you had to build up momentum to move left and right, but now it's pretty much instant. This is almost identical to the movement system before, but I've made a few changes. By a few changes, I just mean one, and that one being force mode, which allows me to quickly change the direction of the player's velocity instead of having to build up that velocity like I did before. Then I added some UI to this game. I've added a little canvas with some text that says 0 as the score, and I've made a little script that shows you how much score you have, which is measured in meters. script for this one is quite simple. Let's start at the top. First of all, let's put in using UnityEngine.ui because we're using the UI element of Unity Engine. Next, let's go to the public transform player, which refers to the position of the player so it can relate to the score up the top. Public text score text is just a variable that relates to the score, so you can put that in later in the code. Now to the good bit, the bit that puts it all together. So score text.text equals player position .z .toString 0 in brackets. You're probably extremely confused what the hell I just said there, so let me explain. ToString is supposed to convert a float number to a string number. The difference between a float and a string number is that a string number can be changed by variable. In our case, we're using a transform. So the gist of the script is that we're parenting the score number to the player's location by using string number 0, which is the starting number, to convert the float to a string number to be displayed on the screen as the UI element. In this video, I've programmed a restart scene. You can also change how long it takes for the level to restart, but for now I've got it as 1. Now I'm changing it to 2 to demonstrate that you can change the restart delay to any number you want. Here's the script for the restart level, which I've named Game Manager because it manages pretty much everything about the game from starting it to ending it. Let's start at the top with the using Unity Engine.Scene Management because we're using scene management to actually restart the level. Next up, we have bool gamersEnded equals false, which is just a variable that we can use later in the code. After that, we have public float restart delay, which is basically just how long it takes for the level to restart. By default, it's 1, but you can change it at any time. Since it's a public float, you can change it in the inspector instead of having to go into the code and change it. We can skip the next few lines of code because that's for later in the video. Let's move on down to the public void end game, which is basically so you can end the game. So if gamersEnded equals false, gamersEnded equals true, debug log, it will just say game over in the debug log, and invoke restart the game and essentially just restart the entire scene. Lastly, we have void restart, which actually just restarts the entire thing. So scene manager.load scene and brackets scene manager.get active scene, which is the scene that you're in now, and then just restart it. Now that we've laid the groundwork in the game manager, it's time to change some code and other aspects. So at the bottom here, I've added a new section. If RB, which is rigid body, .position.y is greater than -1f, the game will end. So if you go off the platform, the game will automatically end. Before it would just go on forever. Moving on back to player collision again. I've only added one line of code here, which is just find object type, game manager, and then end game, which just ends the game once you've hit an obstacle. Pretty easy, pretty simple, works fine. This little clip, I'll show you how I've made multiple levels and how I've transitioned between them. Here I've made a little end block with a little script in the game manager that I've mentioned previously. Once the block's gone through this, he'll play a little animation and transition to the next level. Now that the level's completed, a little error should show up in the bottom corner. There it is. That's saying that there's no more levels to load because we've gone through all 3. Going back to the game object, we're going to go over those 2 lines of code that I skipped on last time. Public game object UI, which is just basically just tying into the little animation I made previously that you saw. And public void complete level, which is making a reference to the end trigger script that I'm going to show later on. And level complete UI.set active true. So that's just activating it. Moving on to the next script, we have the ender trigger script, which is the little box that was in the video that I mentioned previously. So private void on trigger enter, so when you enter the little box, the game manager complete will commence, so the game will finish and move on to the next one. The next script is the load next level script. So this basically just loads the next level and shows the animation that I made. So public void load next level scene manager dot load scene in brackets scene manager dot get active scene, and this build index thing, which is a little tab that pops up and you can put the levels in order. So build index +1, so it always moves on to the next level. So I don't have to put in like the names of the levels and stuff like that. I can just keep adding levels and just use this same code. Here I've made a little menu screen that takes you to the first level. I'll show you that later, but here's the code for it. I've also done the same thing for the quit screen at the end of the game. It doesn't actually quit the game, it just has a little debug log that says quit, because even if you did put the real code, which would just be application.quit, it wouldn't actually work unless I exported the game. Now it's time to show you the full game. I'm going to put on some nice soothing music for you. GLaDOS? Hope you like my little game I made. This is the end of the video, and I hope I get a good mark on this. So, yeah. Thanks for watching the video, and peace out, I guess.